Nowadays, as seen in the emergence of the Internet of Things, we have more access to high granular multivariate time series data. Multivariate time series data analysis plays an important role in various fields such as human healthcare and factory management. To effectively analyze and visualize large to high-dimensional data, dimensionality reduction methods are often used because of their ability to provide a succinct overview of such complex data. However, current dimensionality reduction methods designed for 2D or 3D visualizations do not provide a sufficient capability to analyze multivariate time series data. To support effective analysis of multivariate time series data, we designed a visual analytics framework, MulTiDR. By employing a two-step dimensionality reduction, MulTiDR enables analysts to have a comprehensive overview of the multivariate time series data. Additionally, MulTiDR supports interpreting the two-step dimensionality reduction result by using contrastive learning in conjunction with interactive visualizations. In this video, we provide an overview of the visual interface of MulTiDR. The visual interface consists of multiple views, first of which is the two-step dimensionality reduction view, which shows the dimensionality reduction results in two scatter plots. This example shows the similarities of U.S. counties based on the measurements of their air quality. We select two distinct clusters from the result. The other views then show the related information to the selected clusters. The right view is a supplemental information view. This view visualizes the auxiliary information of the selected points. The feature contribution view in the middle helps analysts understand which features highly contribute to the characteristics of the selected clusters. Having the y-coordinate far from 0 indicates that a feature has a high contribution. By hovering over each feature, we can compare value distributions of the selected feature with histograms. The parametric mapping view, placed at the bottom, helps analysts understand the meaning of the values shown in the x-axis of the histograms. We can see that the values are generated with similar weights for all measures except for the ozone attribute. We demonstrate the usefulness of MulTiDR with one representative case study. From a dynamic network of high school students' communication, we identify and characterize different groups of students. The right-hand side of the two-step dimensionality reduction view shows the similarities of the students based on node features obtained from the network representation learning. Here, we select several distinct clusters to analyze their characteristics in more detail. From the node link diagram, which shows all communications throughout the entire period, we can see that students in the blue cluster are located in the strongly connected regions. In contrast, corresponding students in the orange, red, and teal clusters have fewer connections to others based on the order we have stated. In the feature contribution view, we can see that for each network centrality, the blue and orange clusters generally have strong positive contributions, while the red and teal clusters have strong negative contributions. By selecting several features, we can see that the blue and orange clusters tend to have higher values compared to that of others. This is especially more salient for the blue cluster. From the parametric mapping view, we notice these generated features use large weights around mornings, whereas evenings have close to 0 weights. This indicates that MulTiDR has effectively prioritized the time when students have actively contacted each other more. From the analysis, now we know that during school hours, the students in the blue cluster play a central role in communicating to other students as they have high values for various network centralities. Now, we further categorize these students by using the left-hand side of the two-step dimensionality reduction view, which shows the similarities of the students based on their temporal communication patterns. We can see that each of the currently selected clusters is generally arranged from left to right. However, the blue cluster is separated into two clusters in the far left. We select these two as the new cluster. In the node link diagram, these two clusters are clearly separated into two strongly connected regions at the top and bottom of the view. We can also see that the two clusters have different patterns and feature contributions across time. By looking at the histograms at each time point, we can see that they have high feature values at different time periods. Also, from the parametric mapping view, the feature values represent the network centralities but not the gender. From these observations, the students who play a central role can be further categorized into two groups which have active communications at different time periods. Thank you for watching.